Welcome to the discussion today. We are looking at Form 4 Chemistry under the topic Energy Changes. And the question we have reads, the combustion of ethane in acetylene torches can be represented by the following equation. We have 2 moles of ethane burning in 5 moles of oxygen to produce 4 moles of carbon dioxide plus 2 moles of water. Remember, this is a hydrocarbon, and anytime you burn an hydrocarbon, you'll always get carbon dioxide and water. The question reads, calculate the heat change for the combustion of ethane given the following bond energies. So let us look at the solution to this question. First, we need to look at the bonds that were broken. And in this case now, to find the heat change, we simply take the summation of the enthalpy of the reactants. We minus the summation of the enthalpy of the products. In this case, the reactants represent bond breaking process, and the summation of the products will represent bond formation. In this case now, we need to go down and look at the bonds broken. Bonds broken, in this case, the bonds broken represents the reactant side, and in this case, we are going to have the CH bond, and we have 2 CH bonds times 2 giving us 4, plus we have the C triple bond that is also going to be broken, and since we have 2 moles of the triple bond, we are going to multiply this by 2, then plus, of course, we have 5 moles of oxygen, and if we can represent oxygen like this, we are going to have 5 moles of oxygen being broken in that particular case. So we are going to have 4 times 1 mole of the CH bond requires 415 kilojoules to break, plus we have twice into 1 mole of the triple bond requires 837, plus of course 5 times 1 mole of oxygen requires, this is of course a double bond and not a triple bond, 1 mole requires 498 joules. In this case, we can use a calculator. We have 4 multiplied by 415. We add twice multiplied by 837 plus 5 multiplied by 498, and this one gives us a total of 5824. This one will give us positive 5824 kilojoules. We are giving it a positive because bond breaking is an endothermic process, and therefore the overall heat change will be positive. Then we talk about bonds formed, and in this case the bonds formed are going to be on the side of the products. We are going to have 4 moles of carbon dioxide, and therefore if we can represent this one, we are going to have C. Then of course we have oxygen on one end, we have another oxygen on the other end. This is a double bond, of course. And to break these carbon bonds, we have two of these double bond, but since this one is multiplied by 4, if we have 2, we are going to multiply by 4, and therefore we have a total of 8. Then plus we have hydrogen here. This is water, therefore we are going to break this is oxygen, this is hydrogen. We have 2 oxygen hydrogen bonds times a total of 2, and therefore we are going to have 4 of them. So in this case now, 1 mole of carbon oxygen bond requires a total of carbon oxygen requires a total of 745, but since we have 8 of them, we are going to multiply by 8. We add the hydrogen oxygen bond. The hydrogen oxygen requires 464, but we have 4 of them, and therefore we are going to multiply by 4, and this one is going to give us a total of, we take 8, we multiply by 745, plus we have 4 multiplied by 464, and this gives us a total of 7816. This one is going to be 7816 kilojoules. In this case, since bond formation is an exothermic process, we represent the overall heat change using a negative sign. In this case now, to find the enthalpy heat change of this reaction, which gives us a positive of 5824, we minus the overall heat change for the bond formation, which is 7,816, and if you do this, it will give us, that is 5824 minus 7816. This gives us an overall heat change of 1992 kilojoules, as that is kilojoules per mole, as the overall heat change for the combustion of ethane gas. Thank you for watching and welcome to this channel. And in case you are watching this channel for the first time, kindly take 1 second and click the subscribe button, so that anytime we produce a video like this, you'll automatically be given a notification.